Okay, we're going to work with a formula for finding the inverse of a 2 by 2 matrix. Now, at this point, we're just worrying about a 2 by 2 one as far as finding an inverse of. At a different time, we would deal with 3 by 3s, 4 by 4s, so forth. But if we have a basic matrix, and I just called it A over here, and the elements are just A, B, C, D, whatever numbers are in there. Okay? The inverse, so remember an inverse function had that little -1 power, so that's indicating my inverse, would be 1 divided by the determinant of A. So we've already found the 2 by 2 determinant in the past. We are going to use it now. 1 divided by the determinant of A, and what's happening is A and D switch places, B and C switched signs. Okay, so let's get an example up here. Let's say A equals 2, -3, 4, 1. Here's my matrix. 2, -3, 4, 1. The inverse, right? A inverse would be 1. Get a little -1 up there. 1 divided by the determinant. So remember the determinant was going down minus coming back. Right? There's a different video that covered the determinants. 2 minus a -12 is 14. And so then I'm going to do my changing. The 2 and 1 flip. And the -3 and the 4 change signs. So I just wrote it as negatives on both, but it really just means they're negated, they're changing the sign. So this would become a +3 and a -4. And now where's our scalar multiple that we've done in a previous lesson? I'm going to multiply through by 1/14. So I have 1/14, 3/14, -2/7. We reduce when we can, and 1/7. That would be my inverse. So not a lot to it. The worst part, I think, is remembering the little formula. Otherwise, not a whole lot to it. Let's get a different one up here. We'll call this one B. Again, just a 2 by 2. So we'll go with -5, 2, -4, 2. Something like that. So I just call this one B. It doesn't matter what letter I use here. So here comes B inverse. B inverse. 1 over the determinant, -10 minus -8 is -2. So again, -10 minus -8 is -2. Okay, the -5 and 2 switch places. The -4 and 2 switch signs. This would be a +4 down on the bottom left, -2 up on the top right. So this would mean that B inverse, if I distribute that -½ I'm going to have -1, +1, -2, +5/2. There's my inverse. Right. Sometimes we get some complicated looking fractions here all the way through, and sometimes not. But we're taking our 1 over the determinant and then distributed through, making sure we get the switches. Not a lot going on there. I mean, there's no real point in doing 10 or 12 of these. It's the same process over and over. I want to figure out my determinant, go do my switching, and then multiply by that scalar. So the only thing new is actually getting the things in the right spot from that 2 by 2, getting those elements in the right spot. Determinants review, multiplying by the scalars review, and not a lot going on there. Now let's look at a couple of things regarding these inverses. I'll go with B here. Look at what happens when we take B times B inverse. When we do B times B inverse, if I'm going to multiply the two matrices, so if I said -5, 2, -4, 2, and I multiply it by the inverse, remember we did, this is a review from the multiplication, row by column. So I'd have -5 times -1 plus 2 times -2. -5 times 1 plus 2 times 5/2. -4 times -1 plus 2 times -2. And 2 times 1 plus 2 times 5/2. And again, you can review another video for the multiplying. So we did row by column. Now look at the simplifying here. Here's the important piece. This would give me 5 minus 4 is 1. 4 minus 4 is 0. -5, +5, 0. 2 and 2's cancel. I've got a mistake there. What did I do? There's my mistake. That's a 4. Too bad you're on a video. You can't tell me that I screwed that up, right? That was a -4. So -4 plus 5 would be 1. Now look what we came up with. Remember from previous lesson, that's identity subscript of 2. Okay, identity subscript of 2. And another example came up there that I've talked about, not really in this video, but in others. Hey, a lot of the computation, pretty simple computation, but those careless mistakes are bound to happen because there's so many of them. And I certainly forgot my -4 there, and it kind of blew things up, but I got it corrected. Just watch your signs, like I've said before. We're all going to make those careless mistakes when you go through and you're doing a lot of the different processes. But here's the important thing. So if I multiply an original matrix by its inverse, I get the identity. Now we're only doing 2 by 2's here, but if I multiplied a 3 by 3 by its inverse 3 by 3, I would get an I subscript of 3. It doesn't matter what size you start with. If you multiply a square matrix by its inverse, and we're only talking about square matrices, 2 by 2, 3 by 3, 4 by 4, you will get its identity matrix. So let's take this thing a little bit further. All right. What if I said something like this? I'm going to leave that formula over there. Solve system using inverse matrix. Solve a system using an inverse matrix. Right, so let me get a system up here. We're going to go with 3x minus 4y equals 1. Just going to see what I wrote down here. -2x plus 3y equals 5. Okay, so just a 2 by 2 system. You've solved this algebraically, you've solved it doing row operations or Gaussian elimination, you've solved it using Cramer's rule. Now we're just looking at another method of solving it, right? All of them will give you the same answer. Right? Using inverses. We have what we call this base matrix right here that we saw back when kind of you're doing Cramer's rule, if you've already done Cramer's rule, where I could say something like, I'll say A equals 3, -4, -2, 3. So there's that base matrix. Right? And again, I'm just calling it A, and it doesn't matter what it is. I'm just saying, hey, that's the X and Y columns. Right? And I'll call B the 1 and the 5. There's my answer matrix. Right? So I have my original matrix and my answer matrix. What I want to find is the inverse of A. Okay, so what we're going to do is find A inverse, because there's my 2 by 2. Okay. So A inverse will equal 1 over the determinant. 9 minus 8 is 1. So in this case, the determinant's 1, so we're not going to have to worry about distributing. But it's not always going to be 1. We saw that in the last ones we did. Whenever I flip these two, even though they're the same number, change the sign on the others. Then I distribute. A inverse would just be 3, 4, 2, 3. 3, 4, 2, 3. There's my inverse piece. Now, what I know is, Right? If I multiply the inverse times the original, I get that identity matrix. Okay, inverse times the original, I get the identity. So basically what I've got here is I've got A on one side and B on the other side. If we're thinking of these two guys, there was my A one equals my B one. That's what I'm looking for. That's where the equations were coming from. Well, if I multiply the left side by the inverse, so if I did A inverse times A, then I have to do the right side by the inverse. And that's your old equation property. If you do something to one side, you've got to do it the other. So if I multiply the left side by A inverse, I've got to multiply the right side by A inverse. And what we just saw was if you multiplied the inverse times the original, we get I sub 2. We're going to get that identity matrix. So that would be 1, 0, 0, 1. There's the identity. Equals. Now we've got to go multiply the other two. All right, so the inverse, 3, 4, 2, 3. My A inverse I found, 3, 4, 2, 3. Now if you want to go back and multiply these two to show you get the inverse like we just did, or not the inverse, the identity, then absolutely go do it. You're going to get this identity. We just know the inverse times the original is that. There's my A inverse. My B matrix was 1, 5. So I have my 2 by 2 times a 2 by 1. Now notice the inverse. If you go back to the multiplication lesson, that inverse has got to be on the left side. Otherwise, you wouldn't be able to multiply it. So I still did left side, doesn't matter. Okay. So now I can multiply. I'm going to have 3 times 1 plus 4 times 5, row by column. 2 times 1 plus 3 times 5, row by column. Let's see, so this would give me 3, it's 23 and 17 it looks like when I put those two together, 23 and 17. This is, now we have the solution because we have the identity matrix. Remember our X and Y column? A's were the X and Y column, so X column, Y column. This means 1X, no Y, so just 1X is 23. No X, 1Y, so 1Y is 17. There's my solution using inverses. So for an inverse, or using an inverse, I can take the inverse of my base matrix, my base 2 by 2, multiply it on both sides. It will produce the identity on one side, giving me just the X and Y. X and Y only because it's a 2 by 2. And then there's my two answers for those pieces. So one application of those inverses there.